Alrighty, good morning, good afternoon, whenever you're watching this, good evening. This is section 5.2, binomial probability distribution and binomial cumulative distribution. First of all, if I haven't mentioned this before, if for some reason you're using an 83 calculator on the 84, it does it very nicely. At least we go to either PDF or CDF. It prompts you for the N, the P, and the X value. When you're doing it with the 83, when you hit either one of those PDF or CDF, it doesn't prompt you. You've got to remember, you've got to put the three values in, the N first, followed by the P, followed by the X. Good thing is it's alphabetical. But remember that you've got to separate each of those values with a comma. So slightly different with the 83. I'm not sure how many people are using the older 83, but that's how it's done, as opposed to what you see here with the 84, where it kind of leads you. It prompts you. So that being said, the first five problems straight away. I mean, you're given an N value, you're given an X, and you're given a P value. Just recall, if you're on the 83, you've got to put the N first, the P second, and the X value third. The X is the same thing we talk about in the PowerPoints as being your R value, your number of successes. For some reason, the 83, 84 have a problem putting an R, they call it an X, but it's the number of successes. So these first five, it gives you everything you need. Just plug them in, and there may be a slight discrepancy, maybe 1/1000th, whatever. Number 6, you got a certain brand of coffee shops. They have a 54% recognition rate in the town. Someone comes in, an executive, he selects a random sample of 10 Coffleton residents, find a probability that exactly 4 out of the 10 recognize the brand. We're looking for exactly 4. When we're looking for exactly, it's always going to be a PDF. You're going to either use PDF or CDF, and sometimes you're using 1 minus the cumulative. In this case here, exactly 4. There it is, 10 trials. There's your probability, and you're looking for exactly 4. Number 7, you've got 300 college students. There's your N value. You have your probability, 0.53. You're looking for the probability of exactly 3. Once again, PDF. 9 trials. There would be 9 surveys, 9 trials. Probability of someone reporting at the end of the profession they closely relate to their major, 53%, and you're looking for the probability of 3. There's your X value. Number 8, very similar. 11% of the people are left-handed. If 8 people are selected, what's the probability of exactly 2? It's PDF. You have your trials, you have your probability, 11%, 0.11. Exactly 2, it's a PDF. Just put the 3 numbers in. It couldn't be much easier. Number 9, pretty much the same thing. Exactly 3 serves in. She's serving it 9 times. Probability she gets her first serve in is 0.48, 48%. You're looking for exactly 3, so it's a PDF. Your X value, number of successes, 3. All right, so finally by number 10, we change a little bit. All right, it says here, test consists of 10 true-false questions. Already I know the probability, my p-value is 0.5. At least 6 correct. So at least 6 would be either 6 or 7 or 8. I'm sorry, this should have been an 8 here, my bad. 6, 7, 8, 9, or 10. That's what you're looking for, but you don't want to do PDF 5 times. What I'm going to do is find a probability of 0, 1, 2, 3, 4, 5. Subtract that answer from 1, and guess what I've got? 6, 7. That should be an 8, my bad. 9 or 10. At least 6 or more. I don't want to do PDF 5 times. I'd rather do cumulative once. Subtract the answer. Now, when I tell it to do cumulative, I have 10 trials. Probability of true-false is 0.5. And notice, I'm including 5. I'm telling it my number of successes is 5. It'll automatically add the answer for 0, 1, 2, 3, 4, and stop when it gets done with 5. All right, I said in college, 33% of the, we already did this one here, no more than 6. All right, let maybe not. I remember the physics things in the minorities. Anyways, no more than 6. So 0 is good, 1's good, 3. Jeez. Once again, if I could hit right, I'd be really dangerous. It should be 0, 1, 2, 3, 4, 5, or 6. No more than 6. All right, 6 is good, but 7's no good, 8's no good, 9's no good, and 10's no good. So you're doing a straight out cumulative. All right, you have 10 trials, probability of getting an ethnic minority is 0.33, and you're going to add, the calculator is going to add with a cumulative, it's going to add the answer for 0, 1, 2, 3, 4, 5, and 6. Let's stop at 6, no more than 6. Fewer than 3. All right, you got 22 components. And did I write these ones? Yeah, I guess I wrote that one correctly. Hallelujah. Anyways, you're looking for fewer than 3. Well, fewer than 3 is 0, 1, or 2. Straight out cumulative. There's no subtraction necessary because you're finding the front end. Only time you have to do any subtraction from 1 is when you're at the back end. All right, you got this. You're starting at 0, you're adding 1, adding your probability of 2. A flat out cumulative. And you get 22 trials, probably of a success 0.07, and you're stopping at 2. 3 or fewer. Well, 3 or fewer, number 13. 3 or fewer. Well, guess what? This should have included the 3. 3 or fewer would be 3 or 2 or 1 or 0. 3 or fewer. All right. So I'm doing the straight out cumulative. I'm not subtracting from 1 because I'm not finding the back end. I'm just finding this front end here. The cumulative starts at 0 and stops when I tell it to stop. So 3 or fewer is going to stop at 3. There's my trials, there's my probability, and I'm going to stop at 3. I just should add this little highlighter right over the 3 over here. And maybe I can do it now. Maybe it's a little too late to do it now. So why make this a mess that I don't have to? So that's the situation.